Okay. Not okay, I guess I should do this too. Wait like 1 or 2 more minutes for your friends to come. Okay, before I start the lecture, while I'm waiting for your friends to come, I emphasize here course evaluation. You have until this Friday to fill that out, and I know you all are busy.
You're an R, aren't you? Yeah, it's a good one.
Of course not.
So, it's not showing yet. Oh, because it's not connected. Okay. Okay. So make sure to fill out the course evaluation. As I say, I really highly value your feedback, and I want to teach the course as best as I can. So I need your feedback. And as some of you know, when you reached out to me at the beginning of the semester or like in the middle, and then you had some suggestions, I try to implement them. So course evaluation just makes the course better. And as I mentioned, not only I know that most of you will be done with this course and probably doesn't matter to you much, but if you saw something in the class that you really enjoyed, if you put that in the course evaluation, and most of you put that, maybe your other instructors start doing the same thing because they think that this was really good in the sense of learning outcome. So it just benefits you. And also if you saw something that you didn't like, also put that there. So I make sure that I implement that, and also my colleagues know that as well. And as I mentioned before, make sure when you read the question, what is A, what is D? Sometimes they say, are you agree with this following sentence? The instructor taught the materials well, something like that. And A is a strongly disagree, D is a strongly agree. So make sure to read the question well, and that doesn't affect your grade, as you know. It's just like before your final, I don't see it. It's anonymous. But if you saw something that you like, I ask you to also mention that in your feedback, so it would be beneficial for me and my job, and as I mentioned, also for you. Any question about course evaluation? And the deadline is Friday, and I never assign extra credit or something for that because I don't want you to just fill out because you feel obligated. If you want to, but it's like really encouraged. Any question about course evaluation? Good? Okay, I go to the next slide that I have for you. My Apple Pen works. Okay, so let me have this a little in the middle. So I wasn't happy about the results of the exam 3, especially because I thought that I'm going too slow. I explained material well, at least I thought, and I tried my best to do the best I can, but at this point I'm not going to just nag to you about like the results and all that. Now we have 1 week. We have 3 sessions, and I want to prepare you as much as I can for final. For that matter, I decided not to cover any new material, so give you the chance to just go back and study the materials well to score very well for the final. And I'm also going to, what I'm going to do this session, Wednesday, Friday, I'm going to have review sessions for each chapter, and I try to be fast and cover as much as materials as I can. And I also included corresponding chapters or sections of the book that I'm talking about in these lectures. So hopefully I cover everything. I may forget about 1 or 2 questions, but if you just study these lectures with me and put the effort, hopefully you can do really well on your final exam. I realize that it would be, if you haven't studied so much so far, going to 38 lectures and then going to slides or listen to them is not feasible. So I want to be as efficient as I can, and you should also be efficient and study with me. Does that make sense? So I try to cover materials fast and kind of review, but you have the slides, you have the book and the slides. Hopefully it doesn't get me into trouble, but at this point, I just care about all of you to learn and do well. And after each lecture, like today, I have extra credit opportunities for you. For instance, for today, at the end of this class, I have 8 questions, each 2 points, and I programmed them on Canvas because that is the easiest. And I have the questions on the slides. I have you to answer them there, and hopefully I didn't mess it up and you'll see what I mean at the end of the class. And there have been confusion about extra credits on Canvas. After we're done with this week's lecture, what I'm going to do, I'm going to download everything and then add those to your points, okay? Or maybe I do that after each class, I guess I'll see. And I delete those quizzes, okay? So it doesn't affect you negatively in any way. Even if you get 0 at the end of this lecture, in this extra credit quiz, it doesn't affect you negatively, okay? Questions? Good? Okay, so even if you failed exam 3, with these extra credits, you can get an A on that. So I feel like that's fairly fair. And hopefully, by the end of this week, if you put effort and study with me, you can also do well on your final, so you don't have to worry about that. Any question about exam 3? And as I said, I have a scantrons of your exam 3. I realized that probably after I leave my office or whatever, people are going to recycle them anyway, and I have the pictures of them in my ZipGrade Scantron software. So I just thought to just return those to you. So here is like, it's just alphabetical, and if you look at the first name in each section, you realize that what the order is. Okay. No question, I'm just going to, so I have the solutions to your exam 3, but I think if, I'm going to have a review session, and if you're struggling with chapter 1 or 2 or 3, it doesn't make much sense for me to explain these now, because I first should explain those. But I included the solutions here, and now you have your Scantron, you had them at home, to your exam itself. And you can just compare and study them, okay? But I'm going to just skip through them for the reason that I just mentioned, because I want to start the review session and we're short on time. Okay, so I'm going to be quick, and try to cover as much as materials as possible. What is atomic number? Can anyone tell me?
Number of protons.
Exactly, number of protons in an atom. And it also equals number of electrons, right? So if you want to know number of electrons in an element, for instance, fluorine, how many electrons it has? 9, right? You go to the periodic table, this number on top is atomic number, which is number of electrons. So if I tell you how many valence electrons fluorine has, exactly, you look at the group number, and by group number I mean we had 2 systems when we wanted to report which group a specific element is. One of them was using A and B letters, right? These ones were main group elements. And hopefully you can read what I'm writing. The other one was transition metals, right? Or transition, short on space, transition metals or transition elements. So group 1A, 2A, 3A, 4A, 5A, 6A, 7A, 8A. So if I ask you what is number of electrons in nitrogen, how many? 5. You look at nitrogen, you say nitrogen is in group 5A, so it has 5 valence electrons. Questions? So what is the number of valence electrons in boron? 3. Boron is in group 3A, it has 3 valence electrons. So I'm going to give you the periodic table in exam, as I'm doing always. So as long as you can locate elements in periodic table, you should be able to find their total number of electrons and valence electrons. Good? And I put the whole page here because I expect you to read the whole page. But if I go word by word, I cannot cover the chapters that we studied this semester, right? I'm trying to summarize everything. So make sure to read them. And if you have any questions, just ask me. And I'm going to schedule more office hours with you this week. So probably it would be in the evenings, but I sent an announcement about that. Starting tomorrow, I'll be having more office hours. And you have your tutoring workshops. I think you might have it like next week too, I'm not sure. But this week for sure you have it. So make sure to go to Sean's tutoring session because for extra credit and also to learn. And I had some students emailing me that now they are getting like, I don't know, B. So if, they should go to tutoring sessions to secure, their grade and all that. So if you are on the, kind of like on the border of A's and B's, so if you go to tutoring sessions, you can secure your A. Does that make sense? So it doesn't hurt to go to tutoring session. And if you go to a tutoring session that you thought your time is wasted, just let me know. So I talk with Dale so we have like more efficient tutoring sessions. But I've never heard that from students. Most of the time students are happy with their tutors. Okay. And here is just like summary of what we talked about. And remember, most elements except hydrogen, helium, lithium, beryllium, and I'm just looking at the periodic table. You have like 2 nice periodic table in this class. Except those, all other elements, they want to reach an octet, meaning that in their valence shell, do you remember that when we had like electrons, we had like different orbits or shells around them? Does this seem familiar to everyone? So most atoms, except the ones that I just mentioned, that they don't have much electrons, they want to reach an octet, meaning that in their valence shell, outermost shell, they want to have the electron configuration of the noble gas before or after them. So for that matter, they reach an octet. For instance, if you have magnesium, what is the number of valence electrons in magnesium? 2, exactly. Magnesium is in group 2A, it's 2. So it has 2 valence electrons in its outer shell. It wants to get rid of them, so it has like a field shell, So basically, if it loses those 2 electrons, it reaches the electron configuration of the noble gas before it. Does that make sense? So metals, if you look at the periodic table, for instance, magnesium, if it loses 2 electrons, it reaches the electron configuration of neon, the noble gas before them. But nonmetals, for instance, chlorine, it has 7 valence electrons. It gains 1 and reaches the electron configuration of argon, the noble gas after it. So nonmetals reach an electron configuration of the noble gas after the metals reach the electron configuration of the noble gas before them. Any question about any of this? And do you remember the Lewis structure? If I tell you, write the Lewis structure of boron or B, you write the element, and we said that the nucleus and the inner electrons, we represent that by kernel, basically just atomic symbol. And valence electron we just put around the element. For boron, the atomic number, basically the atomic number is 5, but boron is in group 3A, so it has 3 valence electrons. We put 3 electrons around it. For carbon is located in group 4A. It has 4 electrons, 4 valence electrons. We put 4 around it, and so on. Are we good with this? And for my 101 class, I asked them, after writing the Lewis structure or dot structure of carbon, how many dots do you see around carbon? The answer would be 4, okay? And I may ask you that too, because these are like review of 101. And here you have like the electron arrangement and electron configuration for different elements in the periodic table. So go through them, make sure I don't specifically ask you electron configuration like 1s2, 2s2, 2p6 and all that. But you should know how many valence electrons an element has, how many they share, and all that good stuff. But as I said, I just included your whole book here, so make sure everything makes sense. Questions? Yes?
Is the final going to be 25 questions or more?
Your final would be 50 questions. I may decide on 40. I guess I'll ask you beforehand. 50 questions each, 4 points, or we can do 40 questions each, 5 points. One of your friends wanted to take the final early. I gave them 40 each, 5 points. So I guess we can put it to a vote, or I don't know. How many prefer 50 questions? How many prefer 40? Okay, so we go with 50. Okay, because if you have 50 questions, more questions you have, if you get one wrong, or like, your grade would be overall higher, and hopefully after we have the review session, you will be prepared, so don't worry about the exam. Great question, thank you. Any other questions? Good. Now, ionic and covalent bonding. Can anyone tell me what was the difference between ionic compounds, covalent compounds?
Covalent share electrons.
Uh-huh.
Ionics transfer.
Exactly. So if you have MgCl2, Cl2, when I'm just rushing, I just like make mistakes. Okay, MgCl2, you have like a cation and anion, right? So your magnesium has lost 2 electrons, your chlorine has gained electrons to reach an octet, each of them, right? So it involves transfer of electrons. But covalent bonds like NH3 or like CH4 or like carbon compounds, the course that we're having, right, most of the compounds, they share electrons. For instance, here, your CH4, your carbon doesn't lose or gain electrons. It doesn't transfer, they share. Okay. Any questions? Okay. And then here you have like the demonstration, and again, make sure to study all the definitions. So for ionic compounds, we have cations and anions, we have transfer of electrons. For covalent bonds and molecular compounds, we don't have transfer of electrons, but still some elements like electrons more than the others. For instance, fluorine, oxygen, nitrogen. They want to attract electrons more than the other element. Okay? So we call that affinity, or like that tendency to attract electrons, electronegativity. Okay? So electronegative atoms accept electrons and form anions. I guess here we're talking about like in the sense of ionic compounds, but I'm going to also write this here. Electronegativity is the tendency or affinity to attract electrons. And in the next slides, I also give you like some examples I have like from your book. So in general, if you have, for instance, HCl, okay, and we have like the electronegativity table that I'm going to show you. This Cl likes to attract electrons more than hydrogen. It's more electronegative, okay? And when the electronegativity of the elements in a compound are different, we call that compound a polar compound. But if the electronegativity of both elements are the same, if you have like all the diatomic molecules, if you have like just one type of atom in a molecule, so both nitrogens, and nitrogen has a, what was it? I think nitrogen has, so if we have like the Lewis structure, 1, 2, 3, 4, 5, and then 1, 2, 3, 4, 5, and then nitrogen has a triple bond. That I'm going to talk about it momentarily. So always I just write it like this, so I remember, how many bonds it has, and then write it like this. But in general, what I'm trying to get at, if you have the same element in your molecule, you have a non-polar compound. And here I write HCl here, so won't be confusing. HCl is polar, and then if you have like the same element, you have non-polar. And we have like some other non-polar compounds that I'm going to talk about too. But is it clear what is polarity? Polar, non-polar? Questions? Okay, and here you have an example. Study your examples, you may see the same thing in the exam, okay? So study them to make sure that everything makes sense. Basically it's saying that, MgF2, you have like 2 electrons, Mg has 2 electrons, that it loses them, and then each of these fluorine atoms gains that, so all of them reach an octet and are happy. Again, make sure to study the examples. And also problems, feel free to just answer them and then email me if you have any questions about that, But I'm trying to finish this lecture and make time for your extra credit quiz. Okay, and here we talked about covalent bond before, okay? That when 2 atoms, maybe I just zoom on this a little, share 1 or more electrons. And in general, a molecule consists of 2 or more atoms joined by covalent bonds. Is this clear? Questions? And as I said, most of the compounds that we studied in this class, alkanes, alkadines, alkenes, alkynes, all of them are molecular compounds because they share electrons. I was just about to write here. Okay. And do you remember that when you had like the formation of molecules, in this case diatomic molecules, you had an exothermic reaction. An exothermic reactions are reactions in which heat is released. Okay, so if you consider your reactants being in a container or reaction vessel or whatever, when the reaction occurs, heat is being released out of the system to the environment. Good. So I may give you this, and you saw that in your homeworks, And the other thing, make sure to go back, study all your homeworks, quizzes, and all that. You have all of them available on Canvas. So you may see just like repeat of questions. And as I said, usually I just go to quiz statistics, which question that the students got most wrong, I just repeat that. So make sure to study those two, so you know all the answers. And if you have some questions that you want me to answer during the class time, you can also bring them to the class so I can go through them in the class so your friends can benefit from those as well. Okay, bond energy. Do you remember what was bond energy and bond length? If you have 1 mole of covalent bond and then you want to break that covalent bond, the energy necessary is bond energy. Do you remember when you had like bond formation, that reaction was exothermic. Heat was released to create Cl2. So by the same token, if you have Cl2 and you want to break the bond, you should give it energy. Energy is necessary, is required. And bond length is the average distance between 2 covalently bonded atoms. And these are, again, definitions. Make sure to study them well. Questions? And as I said, make sure to read all these pages one word by word to do well in your final. But I'm trying to kind of like summarize everything in 50 minutes or like 40 minutes rather. Okay, so now we're getting real with our class because now we have like carbon compounds. And as we said or implied, our carbon compounds, they have covalent bonds between them. And this is how it started. You have like carbon, and we said the number of valence electrons in carbon is 4. So, because it's in group 4A, we put 4 electrons around it. And then we do the same thing for hydrogen in the sense of dot structure or Lewis structure. What is valence of hydrogen? Number of valence electrons? 1. You put 1 here, and then you have CH4, right? So you have 4 hydrogens. Here, and what we do in Lewis structures, we just connect these 2 dots and we call them a chemical bond or a covalent bond. And in this case, it's a single bond because it's just 1 dash. So that's why anytime that we write a structure, if I give you something like this, right, what you do, you count that you have like one bond here. And the other thing that I introduced to you was like valence. We had like two things. One of them was like number of valence electrons, which was like group number for main group elements. In the sense when you had like the A system, right? 1A, 2A. And let me just go a little down. Okay. And the other one was like valence. So valence was like 8 minus number of valence electrons. So for the case of carbon, number of valence electrons is 4. So 8 minus 4 would be 4. So carbon can form 4 bonds with other atoms. So that's why I just like blocked what I wrote there. If you have something like this, you say, okay, I have 1 bond here, I should have 4 more. So I put here 3 hydrogen. And in this class for like organic chemistry, when we just write carbons, we just fill them out with hydrogens, right? So how many hydrogens should I put here? 2. How many here? 3. So you use that till the rest of chapters. Any question about that? Okay. And then if you have like one of them, you know, now is Cl is like similar to what you did before, but here, you know, chlorine itself, let me just write it, 1, 2, 3, 4, and then you put hydrogen, 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 and then the dot structure for chlorine is 1, 2, 3, 4, 5, 6, 7, and always put the one that is by itself, single, next to the other element because you want to form a bond between them. So that was my bad. Okay, 1, 2, 3, 4. And your book sometimes doesn't write non-bonding electrons. Make sure you write them. So if I asked you in the exam, how many non-bonding electrons exist in the structure of CH3Cl? What is the answer? 6. And if I ask you how many how many electron pairs or non-bonding electron pairs would be 3 pairs, right? 3 pairs. But if I just ask you the number of non-bonding electrons, you just count them individually. Questions? You're good? Huh. Yeah, I wouldn't do that. You know, I just wanted to originally kind of like giving you like applications of what we learned and all that. But when I saw the results of exam 3, I was kind of like scared. So that's why I'm doing what I'm doing. Hopefully, how many of you think that this is helpful? Okay, how many of you wanted me to cover new materials? Okay, so hopefully the class is not boring for most of you, and then you can benefit from this. Okay, so now if you have like more atoms in our compound, for instance, if you have C2H6, and we're going to talk in more detail about these compounds next class when I'm reviewing them. But if you just want to write the Lewis structure based on the things that you knew before, you put 4 electrons around that, and you have like 4 electrons around this, and then for each of the other hydrogens, you just put them around these carbons, right? And then you connect them with these dashes, right? And you should count them, make sure that each of them, except hydrogen, that it doesn't have, you know, it just have 1 electron, so the noble gas after that, it has just 2 electrons. So it doesn't reach an octet, it reaches a duet. Except that, all other elements, including carbon that we're dealing with, you should count to make sure you have 8 electrons. So 1, 2, 3, 4, 5, 6, 7, 8. And that is what we mean with covalent bond, because now this carbon is sharing electrons with hydrogen. So it has 8 electrons around it. And then this hydrogen, for instance, it has like 1, 2. So it's also sharing electrons with carbons and all that. But now, after we progress with the lectures and all that, you see that we just don't need to write Lewis structure for all the elements. We just remember, that carbon, has a valence of 4. It has 1 bond here, so we have 3 hydrogens here, 3 hydrogens there. Okay, and also remember that in order, to break ethane to 2 methyl radicals, and I'm going to talk about naming in the next class. But if you want to break this ethane molecule, we should spend, or we should give them heat. It's something that, so the reaction is endothermic. And a radical is a molecular fragment with an odd number of shared electrons. So this is the definition of radical. And all the methyl, ethyl, propyl, all that good stuff that we learned, these are radicals. So the radical is a molecular fragment with an odd number of shared electrons. And study the definitions well. Sometimes you know how to name complex structures, and I tell you what is a radical. And then I give you a molecular fragment with an even number of shared electrons, something like that, or say odd number of shared electrons. And then you just mess up a question that is super easy because we didn't pay attention. Read the definitions well and make sure to study everything that I'm including here. Questions? Good. Okay, so this is one question here that most probably you're going to see in your final too. You had it in your quiz and homework. So if I give you the bond length of carbon-carbon and hydrogen-hydrogen, and I ask you to estimate the carbon-hydrogen bond, what would you do? Take an average, exactly. And remember, it doesn't necessarily, the number that you see doesn't necessarily need to be an exact number of the average that you see. It can be around it. But the point is that if I give you this number for I tell you this is the carbon-carbon bond, and I give you this number, and I say, okay, let me see. Let me just read it. Okay, says, what do you expect the length of carbon-carbon bond? So here, hydrogen-hydrogen, yeah, that was what I messed up. We have that much angstrom, and then carbon-carbon is 1.54. Okay, so if I say which of the following can be the bond length of CH, okay, and one answer would be 1.09, the other would be 0.47, the other would be okay, which one is the answer? A, right? So this one is the actual number, okay? And what I'm saying is that it doesn't necessarily, even if I give you 1.08, that still can be, okay? Based on the knowledge information that I gave you. But it cannot be exactly hydrogen-hydrogen bonds, or exactly carbon-carbon bond, or below 0.74 or above, or above the 1.54. It should be in the range, something lower between them and then closer to the average. Does that make sense? Questions? So you see something really similar in your exam. Okay, catenation. Can anyone remember what was catenation? We just talked about that forever. Exactly. So if you had a continuous carbon chain, we call this affinity or ability of an element to form chains of its own atoms through covalent bonding. We call that catenation. So I may give you the same thing, but here I say through ionic bonding. So that would be false, right? Or I said the ability of an element to form chains of other atoms or chains with other atoms through covalent bonds. Okay. So also make sure to go through the examples again, and then the problems, you feel really bad if you see that all of the questions that I gave you was in the slides. So make sure to study them Well, any questions? Good? Okay, and I already talked about polar covalent bonds, but I'm going to just highlight here covalent bond in which the electron pair is not shared equally between the atoms. So sometimes people think that because when I say non-polar, the electrons are not shared. You know what I mean? Because the sentence, when I say non-polar, and then here it's just like not shared, they think that it should be like that. So I'm just don't want to put wrong ideas in your head. But what I'm saying is that just be careful of the definition. Remember that N2 is non-polar because electron pair is shared equally between the elements. You should have an atom that is more electronegative than the other to have polar covalent bond. And that is all I'm going to say about this slide. Questions? And here is your electronegativity table. And what I always tell students is if you think of metallic character, you can remember electronegativity well too. Remember, when you go to the periodic table, if you look at group 13, 14, or like 3A, 4A, 5A, you have in the middle, a zigzag metalloids, right? And then on top of them, like oxygen, nitrogen, fluorine, you have like non-metals. And at the bottom, like bismuth, tin, right, you have metals. So if you just remember that I told you, if you go in the periodic table from up to down, metallic character increases because first you have non-metals, then you are having metals. And then in periodic table, going left to right, metallic character decreases because you have like lithium, sodium, potassium. The other side, you have noble gases and halogens. And electronegativity is the opposite trend. When you go left to right in periodic table, electronegativity increases. Basically, you're having more non-metals. And then up to down in periodic table, electronegativity decreases. Because now you have, first you had non-metals, fluorine, right? And then on down, you have like you have metals. Does that make sense? So by the same token, here, fluorine, oxygen, nitrogen, and then here you have like chlorine too. These are like the most electronegative elements. If you even remember that fluorine is the most electronegative element, you remember that going this way electronegativity decreases, going this way electronegativity decreases. Yes?
Is it the same for like noble gases like H2A?
Noble gases, they don't want to participate in reactions because their outermost shell is filled, so we don't consider them. Great question. Any other questions? Good? Okay, let's see. Okay, finally, if you write the Lewis structure, like what I did for nitrogen, for instance, I had triple bonds. So if you have only one dash, we call that single bond. If you have like two, we call that double bond. And then if you have three, we have like triple bond, okay? And then in the triple bond, 3 electron pairs are shared between two atoms. In double bond, 2 electron pairs are shared between two atoms. And then non-bonding electrons and unshared electron pairs, we talked about them. Basically electrons that they don't participate in covalent bonds or chemical bonds. Questions? Okay. And we're going to talk about alkanes, alkynes in the next class. And hydrocarbons are compounds composed of just hydrogen and carbon atoms. Again, know the definitions. If I give you this and then have this blank, and I say alkanes, alkynes, alkadines, so those are like one category of hydrocarbons, but the general category, when we have hydrogen and carbon, we call them hydrocarbons. Okay? I already talked about valence, and as I said, go through all the examples, make sure that they make sense, and also the problem, solve them too. You may see the same question in the exam, as I said, just emphasizing enough like these ones. Just make sure to answer them. Okay, now open your Canvas. Hopefully all of you can access your Canvas, and if you can't, just email me at the end of the class so I have makeup for you. Hopefully you have access to your Canvas. And you should be able to see extra credit quiz, final exam review for today. And I have 8 questions. I'm going to stay on this slide for like 4 minutes and then go to the next slide, but you also feel free to take a picture and then just start answering the questions. Yes? What's that? Oh, yes. Thank you. And this was the final exam for your friend that wanted to take it early. So at first, I thought maybe I use the same exam, but then I thought that it's just beneficial for you if you have samples.
We can start taking the.
Yes, yeah, just start taking it. And after, as I said, 4 minutes, I'm going to go to the next slide. So if you didn't finish by then, you're free to just take a picture or write the questions. And as I said several times, this is just extra credit. So even if you miss questions, don't worry about that. It doesn't affect your grade negatively. And you're welcome to use your notes too. So I just want for all of you to learn. Yes.
Scroll down to the other questions.
Yes. Just answer 7 questions, that's fine. Yes.
So for 3 and 4, there's like 2 options that would be like really close to the actual answer. But how? I'm trying to think of how to actually ask this. So for number 3, it would be either A or.
So each one has just one correct answer. So I'm talking about, for 3, I'm talking about ionic bonds, right?
Yeah.
And then for number 4, I'm talking about polar covalent bonds. Covalent bonds.
I guess I'm still confused because like magnesium, fluorine, and sodium fluorine, they're in the kind of same spot on like we have one over here on this side, one over here on this side.
But we're talking about polar covalent bonds.
Right. So would both of those not have polar covalent bonds?
So then we have metal, non-metal. What type of bond do we have?
Okay.
Hold on here.
right?
Yeah.
Thank you.
Thank you.
Thank you.
So, covalent bonds would be with metals. No, with not metals. And then ionic is between a metal and a non-metal.
Exactly.
Thank you.
Thank you.
Hi there. So my name's Will Shook. I was just checking in to make sure because I'm gonna be leaving to go home for my brother's.
I'm going to go back to that slide again in case you missed that, but let's answer these ones too. And as always, if I'm just talking for people who are watching this, if you weren't in the class, you're welcome to just reach out to me. I provide makeup for students who couldn't make it to the class. And number 7 is which of the following. I had like the mouse. Yes?
We don't have question A on the canvas.
Huh. Didn't I? Okay, I'll try to generate it real quick. Just bear with me. I'm going to add question 8.
Could we go back to the first kind of group of questions?
Okay, I'll
And then
do, yes. Can you guys see number 8 now? Can you refresh your page? I mean, it does. If it doesn't work out, that's fine. I feel like it should. Okay, let me do a student view. Take the quiz. Okay, I am seeing the 8th question as well. You guys cannot see? Okay.
It's probably since we were already in the quiz.
If you edit it out of the quiz and then go back into it, it should. No.
Okay. Thank you. Okay, everyone is good with like the first 4 questions? Do you want me to go back to those?
I need to go back.
Okay.